So what is it called? What do you think? Square root. Let's go see what it looks like. What values should we choose for x? Should we choose -2 and -1? Why should we not choose -2 and -1? You can't square root a negative? You can't square root a negative yet. That's some foreshadowing. Yes, it is. Yes, it is. Right now, you can't square root a negative. I can. You will be able to before the end of the year, okay? But even then, we wouldn't be able to graph it, just for the record, okay, on a graph like this. So how about if we just avoid negatives right now, okay? So what do you want to start with? 0. Why would we start with 0? Do we know the square root of 0? Oh, it's 0. Okay. What do we want to do next? 1. Why would we choose 1 next? Do we know the square root of 1? Well, what do you think we might choose next then? Why would we choose 4? Because we know the square root of 4. Could we choose 2 and 3? Yes, but we'd have to find a calculator and press buttons, and oh, that's so tiring, right? Why don't we just choose numbers that we know the square root of? What's the square root of 4? 2. So what's the next x value that we should choose? 9. What's the square root of 9? 3. And think about it this way. If you didn't know what the next one was, look at the y column. What's happening with the y's? Oh, so what do we want this to be? A 4, so 16. Very good. Guys, that is something called numeracy. That's your comfortableness with numbers. I'm going to work hard this year so that you become a little bit more comfortable with numbers. Did we have to use the calculator on any of that? No, because we know those basic math facts, but you're not comfortable with them, so I'm going to work to make you comfortable with them. Not make you, but help you become more comfortable. Is that fair? Okay, let's plot these points, please. Uh-oh. What do I do? Is this where I freak out? Faith, are you sure you don't want to freak out right here? 16, 4? Can I graph 16, 4? No, it only goes over to 10. I just kind of skip it, right? I know that I know there's another point out there, so for sure when I graph this, I can for sure know that there's an arrow, don't I? Because I know there's another point. How did I know I could connect the dots? Because I'm given an equation and I know it is continuous. Excellent. What is my x-intercept? Where does it cross the x-axis? 0, 0. Where does it cross the y-axis? What's the y-intercept? Excellent. So once again, it's the same point, right? Okay. What's the domain of this function? How far left does it go? To 0. So how far right does it go? Excellent. X is greater than or equal to 0. Or from 0 to infinity. Right? Okay. What about the range? How far down does it go? Oh, to 0? And how far up does it go? All the way. So what do I write for range? Y is greater than or equal to 0. Okay. Or 0 to infinity. Very good. What about the maximum? What's the highest point that it gets to? So what's the maximum? There's none. If it goes to infinity, there's not a maximum. What about the minimum? What's the lowest point it gets to? 0, 0. Very good. Intervals of increase. Look at the graph, and if we're reading from left to right, where is it increasing? Where is it rising? Doesn't it start rising right here? Yeah? So basically 0 to infinity. So look at my intervals of increase and then look at my domain and tell me the difference. Look at these two. Why do we not have a bracket here? We don't increase at a point, right? We increase after that point, so that 0 is not included. It's only after that that I start increasing. Everybody okay with that? Okay. What about my interval of decrease? Reading from left to right, where is it decreasing? Where is it falling? It's not, so it's none. Good. As x is going to negative infinity, as we're going to the left, what's happening? Where is it going to? 0. As we're going to the right, it's going to infinity. Excellent. Someone asked me a question. Do you remember the rules about that? Okay, somebody asked me a question. Somebody tell Daniel the rules of that because he doesn't know. So a question you have or a question you think somebody else might have. Or if you just want to talk over part of it again. Yes, ma'am. Minimum and maximum, are they always going to be the same? Decrease, interval, decrease, are they always going to be the same? Are they the same as the ones that you did yesterday? They're not, right? When we did the linear function, these were both none on a linear function, weren't they? Okay. Interval of increase, for a linear function, this was infinity to infinity, and there was no decrease, right? So, square root function has a minimum maximum that looks like this. It may or may not be similar or the same as another parent function, but each parent function stands alone. Good question. Anybody else have anything? So we're going to do part of this one, but not all of it. Okay? First of all, anybody know what it's called? If this one's a square root, is there a little baby number right here? There is. It's a 2, but we don't ever write it because that's the most common use of that sign, right? That sign is actually not called a square root. Do you know that? This sign is actually called a radical. Do you remember that? Okay. We most commonly use it for a square root, though, so we don't have to write the little baby 2. We have to write the little baby 3 because that little baby 3 tells us it's not a square root, it is a cube root. And for the record, mathematicians don't call it a little baby 3, just for the record, okay? It's a root. So let's look at it first of all. Let's look at let's go to the table, fill out the table. What kind of numbers do we need to choose here? So 0, I heard somebody say 0. Is that a good one to choose? Okay. So what we have to figure out is what times what equals 0. Okay, so that's a good one. We could do 1. What times what equals 1? 1. Eight. We could do 8. What times what equals 8? 2. Now, could you do a number like 2 or 5? You could, but again, those would be decimals, right? And we're trying to pick like numbers that we know for sure. Yes, ma'am. That was a good joke. Could we choose -1? What times itself equals -1? -1. We couldn't choose negative numbers here, could we? Because it was an even root. Maybe this might be giving away, like a spoiler for later in the year. But if it's an even root, like a square root or a fourth root or a sixth root, you can't have negative numbers under there. Okay? But if it's an odd root, like 3 or 5 or 7, you can have negatives under your root. So what else do I want to choose here then? How about -8? What times itself equals -8? -2. Would you please plot those points on your graph? Now I have to tell you something that happened this morning. Okay? Our table looked almost exactly like this morning, and I was looking at some graphs, and there was a graph that was super, super weird. Because they went here and here and here and here and here. You guys understand we're not doing a dot to dot here, right? It's not like those books where you went from 1 to 2 to 3 to 4. These don't go in order necessarily. The way that they are here on this table is how we talked about them, right? Our conversation. What order am I connecting these dots in? In this case, left to right, like a logical order. So it should look something like that, right? Okay, just making sure. I didn't make fun of that person. I'm not making fun of them now. I'm trying to explain what their thought process was, which I understand, but I helped them figure it out. Does that make sense? Okay. Anybody have any questions about this graph or this table, where we got any of that? Okay. I'm not going to do the rest of this for you. You're going to do this later. I just needed to have the conversation about negative numbers and cube roots. Okay. Now, look up at the screen real quick. What do you notice about these two equations? Look at this equation right here, and look at this equation right here. They are the same. Okay? They are the same. Where is the variable? It's in the exponent. So what are these called? What kind of functions are they? Exponential. Okay? The difference comes after the equation, after the function. Because this says that the b value, the base of the function, has to be between 0 and 1. And this says the b value has to be greater than 1. So they are going to look different, aren't they? They're both exponential. So I'm going to go ahead and write exponential in both boxes, but I'm going to leave myself a little bit of room there. So if you think you know what the other part of this, you be quiet for a second. I'm very glad that you know it, but I want everyone to get to see it. Is that fair? Okay. So let's talk just about this top one for a moment. What do you think is the most common number if I said to you, what is a number between 0 and 1? A half, right? 0.5 or a half. So for this equation and table right here, this graph and table, can we all please use 1/2 to the x power? Just so that we have a common equation that we're using. Because how many numbers are between 0 and 1? A ton, right? An infinite number, actually. I know that seems super weird, but there's an infinite number in between 0 and 1. Okay? What about this one? When b is greater than 1, what's the most common number you think people choose when I say pick a number greater than 1? 2. So let's make this one y equals 2 to the x power. Some of this you might remember from Algebra 1, and if you do, great. But I need to remind you of some things, and if you don't remember them, I need you to trust me for a while until we get to the exponential function section and we can really go into some depth on it. You okay with that? Okay. So if we're choosing a table right here, I would like us to use these numbers. Do you guys write your 2's differently sometimes than each other? Okay, just making sure it wasn't just me. That's just a 2. I know it's a weird looking 2. Please don't judge it. I mean, you can. It's your choice, but... Does your look like mine? Yes, no, I don't know, maybe so. Okay. You got the top one done? Okay. Bottom one? What? We'll talk about that in just a second if you can wait. Is that okay? It's a good question. I'm just not ready for it yet. Or Tuesday. That's y'all's bell. Yeah, it's time to go. I'm going to finish drawing this graph so I can get it on the... Whoop. Oh, yeah, can we say this real quick, what it is? What's happening from left to right on this one? It's decaying. And this one is? Growth. Okay, but we will get that written down on when we meet again. Okay? Have a great day. Amazing.